Welcome to Easy Math TV. This is another video of our series on how to use R in statistics, and this is just a walkthrough of Lab 3. There are 9 labs altogether for this course, and this is the third one on using sampling from a distribution, from a population distribution, to try to estimate what the mean of that population is. And we're going to be using some data from real estate data from Ames, Iowa. So I'm going to just type into my console here. There's 2 commands. We're downloading a file that is our overall data set on Ames, Iowa real estate data, and then we're going to load it into our environment. So it's basically 2 commands. Okay, so there it is up in our environment, and we see if we were to expand that, there's a lot of variables, a lot of them. I think it's 82 variables altogether. We're going to be concerned with only 2 of them for this lab. One of them is going to be area of homes in square feet, and the other one is the sale price. So this video is going to show you everything that you need to do for the lab with regard to the area, the living area, like living space of each home. And then you're going to repeat the entire thing for the price. So let's get right to it. The first two things we need to do is just give a name to the area, because I don't want to have to keep typing Ames $gr.liv.area all the time. So we're just going to call it area, and then we're going to assign the name price to all of our price data. Okay, so you can see that here. We're just shortening it up so that instead of having to type this lengthy name for the area and name for the price, we're just going to call it area and price. And what it did was it extracted that data from the big Ames data file, and now it stored it into its own separate variables that we're just calling area and price. So the first part of the lab is to explore our population data. So so you'll notice in the lower right, I actually have the plots tab showing, and I'm just doing everything in the console right now. So all of the code that you see here is provided in the document that has all the R code in it, and you just copy and paste. So the first thing we're going to do is we're going to get summary data, and this is actually going to give us population parameters, not just statistics. So we're going to get a summary of area, a histogram of area, and I want to see a box plot of it as well. And let's just see what that is. So scrolling to the left, here's the histogram, and what's kind of invisible on the histogram, because these rectangles are just so high, just so tall here, that the data that goes, there's obviously some values that are going off to the right here. It's just really difficult to see them because the rectangles are so tall in the rest of the histogram that that it's basically invisible to see these values on the right. But if we look at the box plot, you can see all those upper values as dots here. So they all appear to be outliers there. You'll notice the minimum square feet is 334. So this probably includes apartments, by the way. And the first quartile is 1,126. The median is 1,442. The mean is 1,500. So the median and the mean are really not that far apart from each other. the third quartile is 1,743, but then the maximum is 5,642. So I will leave it up to you to decide what the shape of this data is. You will be commenting on that in your answer to the first exercise. In addition to just getting summary statistics, though, I want to take a closer look at those outliers. So I've got a bunch of code here that I've added this into the lab from the original one. So there's a bunch of lines here that we need to compute. The first one is like it's going to basically assign a true or false value to whether the area is greater than the the upper whisker. So you can see where the upper whisker is here of our box plot. And we want to know if an area is outside of that whisker, we're going to label it true. And if it's not outside of that whisker, we're going to label it false. And then we're going to get a list of those outliers based on just taking from that, basically from that comparison that we just did, only the things that were true are going to be in our list of outliers. Then we're going to print that. And I want to also see how many of them there were. So let's hit enter. So here's a list of all of our outliers. And these were all basically when we compared these numbers to the median plus 2 times the interquartile range, it returned true. So these were all those dots that we're seeing on our box and whisker plot. That's what these values are. And then we're seeing that there's 72 of them. And I mean, while that may seem like a lot, if we look at the original data set, the Ames housing, there are 2,930 properties in this data set, and only 72 of those 2,930 are in fact outliers. So the next thing we're going to do before we answer exercise 2 is we're going to use a sample of this data. So like it's not practical usually to try to evaluate like a population based on the entire population. You can't always measure the entire population. So what we're going to do is we're going to take a sample of these values, and we're going to calculate the mean of it, and we're also going to see a histogram of it. So I'm going to call it sample 1, sample underscore 1, and that is the sample function in R. So sample parenthesis area comma 50. So we're going to take 50 values. This is a simple random sample, and then I'm going to make a histogram of it. Okay, and then I might as well just put this in there too. We're going to calculate the mean. There we go. So that was just a random sample of values from our area, from just the area in square feet. Okay, this is a random sample. So I'm going to leave it up to you to comment on the overall distribution of that sample. What does that distribution look like? And also, we see that the mean is 1,396.22. All right. So, so that's basically an average of a sample of 50 households from this population. And you can even, if you wanted to, you could do a box plot of that as well. Now we're going to repeat that same process, but this time we're going to call it sample 2. So let's take a second sample. Sample 2 is going to be another random sample from the area vector, of 50 values. We're going to take a histogram of that, and we're going to calculate the mean of that. So this is another sample, and they can look pretty different from each other, just as an overall kind of thing. But again, comment on the distribution or the shape of that sample of 50, and then the mean is 1,499.6, which is extremely close to the actual population mean. It just happens to be. Anyway, you can comment on that. And so now, seeing all of these things, you can now answer exercise 3 of the lab. So exercise 2 was commenting on sample 1, and exercise 3 is commenting on sample 2. So then the last thing that we want to do, and this is basically the crux of this lab, is we're going to look at 5,000 samples from this population. And we're going to take the mean of each of those 5,000 samples. And then what I'd like to do is just take a look at how just the mean itself is distributed. Okay, so this is the code that we're going to need. We're going to create our sample means of each sample of size 50. And that's basically, we just have to create an empty vector, and then we're going to use a for loop that's going to repeat itself 5,000 times to create all of the sample means that we need. And then we're going to make a histogram of those sample means. So this is not just a random sample from our area vector. This is 5,000 samples from the area vector, and each of those 5,000 samples, we calculated the mean of that. So what you're seeing here is a histogram of all of those sample means, okay? Not just the samples themselves, but the sample means. And there are 5,000 of them. So then now, once you see that histogram, you can answer exercise 4. You can also so notice that we put those sample means into this vector that we're calling sample underscore means underscore of 50. So that is all of our sample means. So, you can even over here in the console, just to help yourself to understand what those actually look like, we can print like the first 20 values of it, I guess. So let's look at the sample means of 50, 1:20, bracket 1:20. And so that's the first 20 sample means. So each of these was calculated as a mean from a sample of size 50. Okay, so we took samples of size 50, we calculated their mean, and then we put them into this. We stored them into this object that we're calling sample means of 50, and there are 5,000 values of those. So R is pretty fast when it comes to that. Creating 5,000 samples of size 50, you would think that it would take quite a long time, but it really doesn't. It happened in a split second. So now that's everything that you need to answer the first 4 exercises, the 4 exercises for the area for the variable called area. And then for your lab, you're going to include all of that, but you're also going to include the repeat all of this everything that you saw here. Repeat everything that you saw here for the price data. Okay, So you may see a very different looking histogram for that. There may not be any outliers at all for that one. But that's going to be up to you. You're going to kind of explore that population data for just the price and comment on outliers, comment on the shape of the population distribution, and then take your samples and see if you can estimate what the population mean is from your sample data. All right? So that's your walkthrough for Lab 3. Like, subscribe, comment down below, and share these videos with others if you think they'll find them useful. And I'll see you in the next video.